Welcome. Thanks for visiting and having an interest in non-locality. I assume you have a background in non-locality. My purpose here is to actually explain non-locality, not simply to describe it. I have a lot of concepts to cover, and in a short time, since I regard your time as valuable. We don't know much about the photon. Our first task is to understand it better. A single photon enters a pinhole and diffracts. Its probability of reception waves spread out in space. But when received on a material target, that photon terminates at a point, and its energy is undiminished despite the diffraction. So the photon carries energy that never divides or diffracts in space, and the photon's probability of reception waves spread out in space, yet collapse on reception at a point. These are the two problems needing a solution. I shall begin by regarding the photon as an entity and comparing it to a more familiar entity. Because of mass-energy equality, one would expect both would form entities. The definition of an entity might be something that has a physical presence in a dimension. A carbon-14 atom is an existing entity. It is also unstable with a known half-life. It progresses in time towards its termination, which means decay. All particles theoretically decay. Carbon-14 does so in measurable time. This atom obviously has rest mass, which I call its essential identity. It also has progression toward probable decay, which I shall call its potential identity. A photon is an occurring entity. It has kinetic energy as its essential identity, but photon waves progress through space toward possible termination, which means reception. These waves constitute the photon's potential identity. Here are two entities with a certain formal symmetry. One exists, one occurs. Each progress in a single dimension, space or time, toward termination. Our two identities have essential identities of rest mass and kinetic energy. It turns out that neither of these identities are divisible in one dimension. You can't divide rest mass in time, and we have already seen that pinholes or slits cannot divide photon kinetic energy in space. This suggests an ontological rule for entities. They cannot be divided in a dimension where they do not reside. Rest mass cannot be divided in time because it doesn't reside there. Hence, photon kinetic energy can't be divided in space because it doesn't reside there. And if photon kinetic energy is physically real, and it certainly is, then it must reside in the time dimension. It is the photon's potential identity, its speed of light probable reception waves, that travel in space. To conceptualize how a photon's essential identity, energy, resides in time, consider how a photon is created. Work done on a charge creates the kinetic energy a photon possesses. This kinetic energy must reside in some dimension to be available for transfer later to a material target. By residing in time, photon energy is safe from diffraction or partition, so this solves the first photon issue I cited at the beginning. This photon kinetic energy is pure oscillation without rest mass. As pure occurrence, it belongs in time, not in space, just as pure existing rest mass belongs in space, not in time. Although this energy is in time, it is still accessible in space via events, specifically for photon kinetic energy a reception event on a material target. By the same token, your computer keyboard and your chair reside in space, but they are still accessible over time via events, as when you do a keystroke event on one or a sit-down event on the other. Let me sum up the arguments for photon energy residing in time, arguments I must abbreviate for this video. First is the fact that inertial rest mass resides in space. If nature is symmetrical, then photon energy should reside in time. Entities can't reside in or occupy two dimensions. Mass only occupies space. Mass is not divisible in time because it doesn't reside there. It follows that photon energy is not divisible in space, as we have seen, simply because it doesn't reside there. Existence and occurrence should have equal status in reality, as E equals mc squared tells us. Both rest mass and kinetic energy should form entities in a dimension. Physics already has pure oscillation. Quantum field theory, QFT, features vacuum fluctuations. They are the oscillation of nothing. What I am proposing is the oscillation as created by work done. Recognizing that photon energy resides in time explains why it can never be diffracted by space-residing pinholes or slits, or divided by a beam splitter. Next, we need to consider why photon energy is received on a material target at a space point. Photon energy resides in time and can only be received as an event on a rest mass target residing in space. Because energy and target are orthogonal, their interaction cannot be continuous, nor can it follow strict causality. Photon reception on a target is therefore a probabilistic intersection event between photon kinetic energy residing in time and target rest mass residing in space. The only way the essential identities of photon and orthogonal target can meet and intersect is via an event which combines kinetic energy from time with rest mass from space. By involving both rest mass target and photon kinetic energy, an event is discretely located in both space and time. Because the photon reception event occurs at a space point and delivers energy and momentum, there is the inevitable naive analogy made with particle impact, even though the photon has no rest mass. The photon is mysterious, and we humans never pass up an opportunity to interpret it with constructs drawn from particle physics and common experience. Even the great Richard Feynman fell into this trap. Consider the missteps people have committed in analyzing the photon. First, there is the influence of language. Once we name something as a noun, we think of it as a unitary object. For non-locality especially, experimenters focus on photon quantized energy reception and ignore its probabilistic wave nature. This fosters the assumption that the photon is a particle traveling in space. Second, we fail to question the 19th century view of energy as a mere quantity. Next, we obsess over particle physics and insist that its concepts apply to radiation. Finally, a photon termination event location is not photon location. We can see this distinction between event location and entity location if we switch to material entities. An inertial carbon-14 atom has a defined space location, but progresses in time and has no defined location there. The carbon-14 atom's termination/decay event has a defined time location, but you are not going to project that event time back onto the carbon-14 atom, which never had a time location. That would be foolish. But that type of projection is exactly what we do when we think that the space location of a photon's termination/reception event characterizes the space location of the photon itself. We are conflating an event location with an entity location. We are unconsciously thinking of the photon as a particle in space with its reception revealing its final space location. But the photon is not a particle, and its essential identity, energy, neither resides in nor travels through space. Before looking at non-locality, I wish to expand our knowledge of the photon by examining two long-standing issues in physics. First, how and why do photon probability waves collapse? Second is the photon dualism puzzle as revealed in the double slit and the Mach-Zehnder interferometer. A single photon enters a pinhole and undergoes diffraction. The waves coming from the pinhole are physically real and can be modeled mathematically. The waves are continuous and cover all available space paths, but with differing intensities. A photon termination event occurs on just one path. All remaining paths collapse non-locally. So how can we explain this? First, these waves have no kinetic energy and no rest mass, hence their collapse does not violate any conservation law. Second, because of E equals mc squared, energy and mass store each other in potential form. Kinetic energy stores potential mass, and rest mass stores potential energy. Photon probability waves in space represent storage from photon energy oscillation. These waves are potential in nature and share the frequency of the photon's time-residing energy. These waves are also dependent. They owe their occurrence, their reality, to the photon oscillating energy in time. Since these waves expand in space while being dependent upon photon energy oscillation and time, they have a single point of failure in an orthogonal dimension. Immaterial, probabilistic waves occurring in space answer to but a single occurring entity in time. When that occurring entity in time, photon energy, ceases via termination, all occurring space waves collapse non-locally. Nature is very subtle in her use of orthogonal dimensions. The photon dualism puzzle is best illustrated with an interferometer rather than with a double slit. A single photon enters the first beam splitter in the Mach-Zehnder interferometer. Photon oscillatory energy residing in time is unaffected by the beam splitter. But the photon's probability waves progressing in space split in two, 50-50, at the beam splitter and follow paths A and B. These two half-strength waves will reunite at the second beam splitter and interfere, thereby demonstrating the wave nature of the photon. Assume our divided photon probability wave is blocked at detector B. The first possibility is that the probability wave triggers photon reception at detector B. Waves on path A collapse, just like redundant waves emanating from a pinhole that strike a target but don't cause termination. This collapse is non-local, as already mentioned. The second possibility is that the half-strength probability wave does not trigger termination at B and simply collapses there without a trace. The collapse of waves at B means photon termination can only take place on path A, where remaining waves progress. It also means there can be no wave interference at the second beam splitter. The Mach-Zehnder interferometer shows us that probability waves blocked on one path may collapse without a trace. This runs counter to our expectations in the world of material objects. When there is no photon termination at B, everybody assumes that the photon, as a unitary object, took, quote, the other path, unquote. In fact, photon probability waves took both paths, and photon oscillatory energy in time took neither path. When you fail to recognize that the photon has an essential identity residing in time and a potential identity progressing in space, photon behavior remains inexplicable, which has been the case for the last 100 years. With the interferometer covered, I will now turn to entanglement. It makes sense that similar entities can bond where they occupy an interval or volume. Adjacent rest mass entities will bond, that is, entangle, in space. A sodium ion and a chloride ion will bond to create salt. Adjacent photon energies will bond, entangle, in the time dimension where they reside. Photon energies occur. They are time adjacent if they are the product of a single event, typically a bigger energy quantum splitting into two smaller quanta. If a high energy photon from a laser enters a crystal, it has a certain probability to split into two lesser entangled photons by what is called parametric down conversion. I have identified two essential identities which only reside in one dimension: rest mass in space, photon energy in time. Residing in one dimension means they are shared by observers in the opposite dimension. Rest masses, like your desk, reside in space, progress or persist in time, and are shared by observers in time. This sharing of an entity's essential identity is remarkable, although we don't think it so. It actually tells us that space and time are orthogonal. That is, residing in one dimension means that which resides is shareable in the alternate dimension. For your desk, its advance over time presents the self-same rest mass to multiple time-separated observers. For the photon, its advance over space presents the self-same photon energy to multiple space-separated observers. Consider a photon's probability of reception wave as it spreads out as a spherical wavefront. Any observer on the leading edge of this expanding wavefront has the possibility of receiving the one and only photon energy. Because photon energy in time is orthogonal to space observers, this energy does not travel in space to present its possible reception to space-separated observers. Travel in space is the task of the photon's potential identity. With this understanding of essential identity sharing, we can now look at entity entangling, starting with the rest mass case. Assume you have two space-stationary, space-adjacent carbon-14 atoms, and they entangle their essential identities. rest mass bonded to rest mass. The joined pair have a defined location in space, but not in time. They progress in time toward termination, which is decay. First one decays, and then the second one decays exactly 1,000 years later. No one is going to claim that the two atoms' rest masses are located 1,000 years apart. The time location of a decay event does not give that time location to the essential identity of an atom. That is to conflate event location with entity location. They are different. The general rule is, don't project the location of an event back onto an entity that never had such a location. From carbon-14 bonding, if you switch energy for rest mass and time for space, you get photon bonding. A photon enters a crystal, divides in two, creating two lesser entangled photons. The photons' occurring essential identities, namely energy, are joined together and located in time. Their potential identities, probabilistic wavefronts of possible reception, progress in space toward termination, that is, reception on a target. The paired photon energies undergo separate receptions on material targets exactly 1,000 kilometers apart. It is incorrect to conclude that the two photons are separated by 1,000 kilometers. The two photon energies are in time and are adjacent there until one creates a reception event. This event has a space location courtesy of the material target, but the energy that initiated this event resided in time and never had a defined space location. Once again, the rule is, don't project the location of an event back onto an entity that never had such a location. Now let's consider the life cycle for two entangled photons. High-energy photons from a laser enter a crystal. A few of them will split into two entangled photons, let's say blue and green in frequency. It is photon oscillatory energy that does the bonding and does so in the time dimension. Together, the two daughter photons conserve the energy and momentum of their parent. Photon energy spin is normally 1, but the joining of two of them yields a spin of 0. Meanwhile, the two photons have potential identities, probability of reception waves, that fan out in space as speed of light wavefronts. Any observer/detector on a wavefront has a small chance to participate in a reception event. Finally, at some distant point in space, the blue photon's wavefront triggers a reception event on a detector at point A. Blue photon energy now exits its time entanglement, and in doing so acquires a right circular spin of 1. Green photon energy simultaneously assumes a left circular spin of 1, thus conserving original total angular momentum of 0. Spin coordination is simultaneous because both photon energies are massless occurrences, adjacent and bonded in the time dimension. Soon the green photon's wavefront triggers a reception on a different detector at point B. Observers at A and B compare notes and decide that the green photon's spin got defined well before any speed of light signal could have arrived from the blue photon. By assuming that a photon's termination event reveals the space location of the photon object, they decide that the photon's spin coordination has violated the principle of locality. They think that the change is non-local, but they are wrong. What we measure of the photon is its essential identity, its energy. This energy residing in time doesn't have to travel through space to reach a distant location. Just as your desk's rest mass residing in space doesn't have to travel through time to reach tomorrow or next week. In both cases, the essential identity, energy or rest mass, is simply universally available for event interaction. That is a simple idea, but not one you will find in any textbook. A correct understanding of the photon's identities resolves both of the great paradoxes of radiation, photon non-locality and photon dualism. It turns out Einstein was right and his critics wrong. There is no spooky action at a distance, because with photon oscillatory energy and time, there is no distance. This presentation is much condensed and supporting arguments have been omitted. My full essay goes beyond the photon and covers additional topics. Probability waves and their collapse are more fully explained, and they are extended to matter in motion. This presentation has treated radiation having no rest mass and inertial rest mass having no kinetic energy. My published essay looks at the combination, the union, of kinetic energy with rest mass entity, giving us familiar matter in motion. Courtesy of its kinetic energy, matter in motion has its own collapsible probability waves, namely de Broglie waves. The photon is energy, and electrons always have energy. Not surprisingly, the two can entangle their energies in time and produce some unique results in the laboratory. Most everyone assumes that the entanglement happens over space between particle rest masses. It actually happens in time between pure oscillatory energies. Uncertainty results from combining oscillatory energy with non-oscillatory rest mass particle. A rest mass particle has neither oscillations nor wave features until you add kinetic energy to it. The electron is wave-like because it always has considerable kinetic energy relative to its small mass. It is not wave-like simply by its tiny rest mass alone. Schrodinger's cat and the measurement problem. Why do waves or quantum states collapse when we measure them? That is the measurement problem, and its most popular example is Schrodinger's cat. Wave collapse treated in this presentation is extended to quantum state collapse in my full essay. Realism in physics. Since the Bell non-locality experiments in the 1980s, non-locality has been taken to prove that realism in physics is dead. So much for that proof. My essay defends realism in physics if you have an interest in that topic. If you have made it this far, my thanks and my congratulations. You have expended a lot of mental effort. The proceeding constitutes a new way of looking at physics. It gets down to the bare metal of physics, what exists and what occurs, and how those constituents, those entities, use dimensions. That is the foundation upon which the rest of physics, including mechanics, is built. But this approach is little understood, and even less is it practiced. Particle physics dominates with its obsession on existing entities residing in space. Occurring entities residing in time are never considered. There are too many new concepts here to absorb in one viewing. If you are truly interested in quantum theory, view this video again. Better yet, read my full essay. Here is my email. Bouquets and brickbats, always welcome. Thanks again for visiting.